Hello guys, welcome back. In the previous video, we have understood what are data types about and variables about. We have seen some small example, how does variable and data type works together. Now let's try to explore something more about data types. So basically data types are three different types. So we can say primary, we can say derived, and we can say user defined. So the basic thing is we try to use mostly the primary. So integer, float, double, char, bool, void. So for using this bool, so we need something called std_bool.h header file. So let's see what are derived. Array pointers and functions are said to be derived. And let's see what is user defined. So user defined comes into picture when you use union, structures, enums, etc. So now let's focus much more onto primary data types. So what are primary data types we have? So let's take the picture of integer. So what is an integer? Basically, an integer we try to only hold integer values. So what are integer values? We can say something with zero, positive, negative. So all these are said to be integer values. So what is the size of the integer data type? Basically, we say the size of integer data type is 4 bytes. And of course, this depends on compiler even. So when you normally say the latest compilers, everything are 64-bit compilers. So 64-bit compilers basically use 4 bytes of memory for integer. Maybe if you go for old fashioned systems, there it only has only 32-bit compilers. So there it might go for 2 bytes. So now when we say 4 bytes, 64-bit compilers comes into picture. And when you say 2 bytes, 32-bit compilers comes into picture. Okay, but what is a byte and what is a bit? So let me just add something more about byte and bit. So when I say bit, so bit is nothing but 0 and 1. So what does machine knows? Bits, zeros and ones. So when you say 1 byte, so 1 byte is basically 8 bits. Means if you say 8 bits, the lowest value that can be possible with 8 bits is 0000 0000, and the highest value that can be possible is 1111 and you make 1111. So these are the ranges. So what basically we have. So it starts from all zeros to all ones. But what is this zeros and ones? So this we normally say it as binary base. So let's try to say something with binary base. Normally, if you see whatever we write in our regular life, we write in this way: hundreds, tens, ones, maybe ones, tens, hundreds, thousands, so on. So if I say I need something like 456, so you take 400s, you take 5 tens, and you take 6 ones. So this is 456. But if I say the same thing in binary, so if you go for decimal, so this is said to be decimal base. In decimal base, so what is the base you have? You have base 10. So if you say in 10, what are the digits allowed in 10? So 0 to 9 are something which are allowed in decimal base. But if you stick to binary base 2, so what do you get? You get something like, so 2, 2, 2, 2. Maybe I can say 2 power 3, 2 power 2, 2 power 1, and 2 power 0. So what is 2 power 3? 8. 2 power 2 is 4. 2 power 1 is 2. 2 power 0 is 1. So this is basically how you have. So now if I say, maybe you take any value. Here if I say 1, 1, maybe 0, 1. So what is this? 1 into 8 is 8. 1 into 4 is 4. 0 into something is 0. 1 into 1 is 1. So this whole value is giving me the value 13. So we can say 13 normally represented in decimal base. The same thing we can represent that in binary base as 1101. So 1101 is the value of 13 in binary base. Similarly, now let's try to understand what are all these zeros and what are all these ones. Maybe now if you range all zeros, if you range all zeros, the value of course would be 0 only. But if you say all ones, so what are these all ones about? Means if you start doing that, so it starts from 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Means you basically start something like 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So this whole adds up and gives us the value, so which is 256. So this all wholes adds up and this gives the value 255. Sorry. So basically you see now the lowest value is 0 and the highest value is 255. Means on an average, how many values do we have? So we have 0 and plus 255. Means we can say there are 256 values for what? For 1 byte. So 256 values for 1 byte. So how normally you can say? Means if I say these 256 values divided into both positive as well as negative. Means if you say positive means there are 128 positive values. And if you say negative, there are 128 negative values even. So when you say 128 positive values, you start something from 0. So 0 to 127 is something. When you say negative 128, you basically start from minus 128 to minus 1. Means we can say combination of both positive and negative that gives up again same 256 values. So minus 128 to 127. So these something are said to be called signed. So when you say signed, both positive and negative comes into picture. When I say something called unsigned, so what is this unsigned? When you say unsigned, only positive values comes into picture, which is 0 to 255 only. Now this we have discussed it only for one byte. Now if I generalize the same thing, I can say minus 2 power 7. So 2 power 7 is 128. So minus 2 power 7 to 2 power 7 is 128 minus 1. So means you can say if something is signed, you can say one byte basically comprises of minus 2 power 7 to 2 power 7 minus 1. Maybe similarly, if I go for unsigned, you basically say 0 to 2 power 8. So what is 2 power 8? Basically 2 power 8 is 256. 256 minus 1 is 255. So you say 0 to 2 power 8 minus 1. Maybe if you generalize this still more completely, I can say minus 2 power n minus 1. So till 2 power n minus 1 minus 1. And this positive things you can say 0 to 2 power n minus 1. So this is complete set of values. Now here when you say n gives the number of bits. N gives the number of bits. Now this is for only one byte. But when you say now integer, what we have discussed. So when you say integer size is 4 bytes. Means now we can generalize and say for integer, the size would be so minus 2 power, maybe if it is positive as well as negative. So you can say minus 2 power 31. So till 2 power 31 minus 1. So this is the lowest value and this is the highest value if you consider signed. But if I consider only unsigned, means only positive values, means you go 0 to 2 power 32 and you say minus 1. So this is what the range. So this is what integer about. In the same fashion, you have different things. But something to just add on, in the same integer, you have different categories. So integer basically has again three things. So one is short, one is int, and one is long. Again, everything is further divided into unsigned and signed. So when you say unsigned, it is only positive. When you say signed, again it is positive and negative combination. So when you say unsigned, you have unsigned short, you have signed short, again unsigned int, unsigned long, and signed long. Means there are basically 6 again different categories. But why do we have this short, int, and long? See, every time we can't use 4 bytes because if you use every time 4 bytes, even though you don't need that amount of memory, you still try to waste. So that's the reason short and long came into picture. So short would be 2 bytes, int would be 4 bytes, and long would be 8 bytes. If something is still not fitting in the range of an integer, then you go for long. So basically these all are integer values only. So then next comes a picture of float. Okay, let's say maybe now if you want to hold something like 110611. So this is an integer value. You can store that absolutely in the integer. But what if I want to store something like, let's say 1011 0.34. So let's say 10,110.34. But this I can't store it in integer because I need something which can hold 0.34 also. Here comes a picture of float. So basically there are two categories. So one is float and the other one is double. Okay, so basically float is a single digit, single point precision. And when you go for double, it is a double point precision. So precision basically you can say it is more accurate. Means here you can say 6 decimal points. Okay, and you can say 15 decimal points precision. So mostly if you compare float and double, so double gives you high accurate values, but float might not give accurate every time. Okay, this is basically about double and float. So when you say the sizes of float as well as double, so basically float goes with 4 bytes. Similarly, if something is more, then you go for double. So double goes with 8 bytes. So float 4 bytes, double 8 bytes. So apart from these two, we also have something called character. So character is nothing but 1 byte. So what do you do in this 1 byte? So in this 1 byte, you hold all the characters, something like character A, character E, maybe let's say character space, full stop, commas, all those things are said to be multiple individual characters. So the size of the character in C programming is 1 byte. So then next we have something like Boolean. So what is this Boolean? But basically, if you want to use this bool, you need to use std bool.h header file. So what is this bool? So basically, bool holds something like true or false. So when you say true, you can also say 1 or you can say 0. You see here in bool, there are only two values. It doesn't matter if you take 1 byte. So the size of bool is only 1 bit. The size of bool is 1 bit. So mostly int, float, double, char, bool, and we also have something called void. So which we won't use at all. So this void is basically used for pointers. So when you say if something is not pointing to something, then it is said to be a void pointer kind of thing. But we cannot go use this for variable declarations because we can't write void num. It doesn't mean, right? Because you're saying there is a number, this is of nothing. So there is no meaning in that. So basically you write int number or float number or char ch, all those things, right? So but there is nothing called void num. So this is nothing. So basically these are the multiple data types. So what you have in C. So all these things we were trying to use in the upcoming sessions. Let's quickly summarize what we have seen so far with the ranges. So these are the different types of ranges what do we have. So when you start from char, so we have 1 byte. So from -128 to 127, which is of signed. When you go for unsigned, that would be from 0 to 255. So these are the ranges. Means if you see for integer, so you can hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically 10 digits you can hold in integer. So that to the maximum of 4. So this is when you go for unsigned. So when you go for signed, maybe you can say, so the 10th digit would be highest is 2. So you go for long. So these are the number of digits what you basically have. So this is for like integers and characters. Let's also quickly see it for our float as well as double. Float is basically of 4 bytes. It is having precision of 6 to 7 decimal digits, and that's the range. Similarly, let's also have a look at for double. So when you see float and double, float is 4 and double is 8 bytes. Double is having 15 decimal digits precision. So that's too big. So basically, when you say accuracy, double comes into picture. So this is a complete table. So where you see the ranges for char, short, int, long, float as well as double. So that's all for this video, guys. Thanks for watching. See you guys in the next one.